Greetings, dear viewers. As our journey in immunology continues with SKA, moving ahead towards the analytical techniques used in this 18th episode of Immunology for Everyone podcast by SKA, we discuss today the sensitive and specific ELISA, a word that rings bells in our minds. We immediately start relating to the test reports from labs stating ELISA positive, ELISA negative. Let's hear it from the expert as to what this means and what all parameters make this inference possible. In the episodes following this one, SKA will discuss the applications and key pointers for those prepping and running this sensitive technique. So keep following, sharing, and interacting with your host.
Hello, my friends. Welcome back to this episode of the Immunology for Everyone podcast. Last time, as you know, we started with a new series of this podcast discussing some of the techniques which are used in the immunology laboratory for the detection of antigen or antibody. And we discussed some of very simple techniques which can be done in any laboratory with a minimum requirement for any sophisticated instruments, and these were based on the principles of immunodiffusion using agarose gels and immunoelectrophoresis. Since we cannot do absolute quantification of the antigen or antibody present in the clinical sample using these techniques, although some level of quantification is possible, yet there are many advanced techniques in the booty which are being done in the laboratories nowadays, which are quite analytical nature, and they are basically very advanced techniques with the possibility of quantifying the antigens. So, and moreover, with the advancement of technology and science, the clinical practice have also become more and more dependent on laboratory-based evidence of any infection, and clinicians normally demand all those, assays before they start the treatment. So the techniques have to be highly sensitive so that they don't miss any presence of a infectious agent or the reaction caused by it, and also it has to be very specific so as not to give a false positive reaction, which means that the techniques should accurately estimate the presence of antigens or antibodies. And these techniques are analytical in the sense that we can not only accurately detect the presence of antigen or antibodies in the clinical samples, but also quantify them, which have become important not only for accurate diagnosis only of the disease, but also help in monitoring the progression of the disease as well as the response to the treatment. So they are very important techniques. So, and you know that all the immunological techniques are based on the interaction of antigen and antibody. So, besides precipitation reactions, now that we discussed in the last episode, these techniques detect the molecular reaction of antigen with the antibody. And most commonly used techniques, which are the analytical in nature, are like radioimmunoassay, then enzyme-linked immunosorbent assay, and then immunofluorescence assays. So we will discuss one by one. The radioimmunoassay, it is called radioimmunoassay because there is a use of radioisotope label, which will label either antigen or antibody, and then there is a sort of in the technique there is a it's a kind of competitive inhibition assay, and the labeled antigen or antibody will compete with the unlabeled antigen which is present in the clinical sample, and then the difference is measured by the use of whatever is remaining unused, labeled, which can give a count. You can do by uh, counting the radioactive component of the reaction. And since this there is only the limitation in this is, although it is a very sensitive assay and has been used for the detection and quantification of hormones in the body, and you know that hormones in the body are circulating in very minute quantities, and they perform their functions, and any disturbance in the hormone at the level of their presence can basically disturb many metabolic reactions. So these techniques are very sensitive, but they use radioisotopes, so there is always a level of health hazard attached to them for the uh, for both for the technician who is doing it as well as for the patients which are undergoing the tests. So there has been a quest for replacement of all these kind of techniques which use radioisotope, just to eliminate the health hazard part of it. So the most amazing techniques which have come up and which are trying to replace these are the enzyme linked immunosorbent assays. And in this, instead of using radioisotope label, we use enzyme labeled antibodies. So it's a modern molecular technique for the detection of antigen antibody interaction with the help of an enzyme instead of a radioisotope. And ELISA is also one of the most sensitive, technique for the detection and presence of any antigen or antibody, as well as for quantification in case of clinical diagnosis of many diseases, and they are being used. So there are many different kinds of ELISAs. So what basically the principle is that antigen or antibody is attached, adsorbed to a solid surface, which invariably a plastic tube, or it can be a micro titer plate. These are made of polystyrene. And the reason why we use these polystyrene based, it can be a paper, nitrocellulose paper also, paper strips. So, because these materials are positively charged by nature, and the coating by the antigen becomes very easy and successful, because we can have the antigen dissolved or diluted in a buffer which is at alkaline pH. So normally we use bicarbonate buffer at pH 9.5 or 6, which is highly alkaline, and at it turns all the proteins into negatively charged. And these negatively charged, when they are incubated overnight on these polystyrene plates, they get coated with a ionic bond, so they are held together. And all kinds of subsequent washings and incubations with subsequent reagents like antibodies and you know mm, um, uh, development of color, all steps, they require a lot of washing. But this ionic bond will not be disturbed if you use all the buffers and at a pH which is closer to neutral. And you can use even detergents. Normally detergents are mixed in the washing buffer, which are non-ionic detergents. So one has to be very cautious about how we do these assays, and be careful that we should not try to disturb the ionic bond. Then it is very easy, and they go by, you have the direct ELISA, which is kind of, you can tag the antigen coating on the plate, and then add a antibody which is conjugated with an enzyme. And most probably the enzymes used are horseradish peroxidase, alkaline phosphatase. These are the enzymes which are tagged. You can get a commercially from a commercial source. and then you add a substrate as per the enzyme which is there. So if there is a immunological reaction, if the antigen is present, the antibody will go and bind to the antigen, and you see there is the enzyme remains there, and you add the substrate which is a chromogenic substance, and that normally is colorless, but as the enzyme hydrolyzes as is the substrate, it changes its color. So change in color leads to development of color, and the intensity of color is directly proportional to the amount of antibody or antigen present in that. So it's a very simple and very sophisticated technique. And then you have indirect ELISA, where you can actually detect the presence of antibody in the clinical sample, and you use the secondary antibody. And then there is a sandwich ELISA, where the two antibodies are generated. One is a capture antibody which is tagged to the plate, and then the clinical sample is added which may or may not have the antigen, and then another antibody which is also against the same antigen but a different epitope, and this antibody is tagged with the enzyme, and so the antigen basically is sandwiched between two types of antibodies which are against the same antigen but different epitopes, and that gives a positive or a negative result. So very very sensitive technique. And then all these three types of ELISAs, they can be basically be converted into a competitive kind of ELISA. The competition ELISA, also known as the blocking ELISA or inhibition ELISA, is perhaps the most complex of all the ELISA techniques, and you can basically adapt any one of these, direct, indirect, or sandwich ELISAs into a competitive format also. The competitive ELISA is predominantly used to measure the concentration of an antigen or antibody in a sample by detecting the interference in an expected signal output, and it is similar to radioimmunoassay. The only thing is that we do not have the radioisotope but an enzyme. So you for the direct ELISA, when it is adapted to competitive ELISA, so it's then we have the sample which may have antibody, and the labeled antibody will compete with it, and you will see the color reaction. And if the antibodies are present in the clinical sample, they will compete and will lead to the reduction in color. And similarly, the other format, you can have the secondary antibody, and in between there is a competition, and you have the competition ELISA. Very nice. So the good, ELISAs are very sensitive, very specific, and quantitative in nature as well. The few points which need to be understood about ELISA, although nowadays we have sophisticated automated ELISA machines which will do the ELISA by robotic, arms. They will add the reagents, washings, and everything is done inside, but they are very expensive. So in a simple laboratory, you can do ELISA yourself. I used to make my own ELISA, quote even the antigen myself. But since you are going to do for cytokine ELISAs, where the antibodies are tagged to the first anti-cytokine antibodies are tagged. They are the capture antibodies, and you add the clinical sample which may have very minute quantities of cytokine, and you may do it for hormones also, and then you add the antibody which can be which is kind of tagged with the enzyme, and you do that sandwich ELISA. So it is a bit difficult to coat with the antibodies because we already discussed that immunoglobulins are basically less charged, so ionic strength of binding is a little weak. So what you can do is there are techniques of making the plates more adhesive using polyl lysine for antibody tagging coating. So the capture antibodies can be coated inside, whereas the antigens, it's not that difficult because the alkaline pH, the negatively charged proteins, they get coated very easily. Then the washing steps, the washing buffer will always contain a non-ionic detergent instead of the ionic detergents which are normally available. So you should look for the non-ionic detergent, and the washing steps have to be really rigorous so that the residual amount of previous antigen should be washed off, or non-specifically adhered components can be washed off, and you get the color, and the color need to be developed uh, for 20 minutes, and then the reaction should be stopped by adding sulfuric acid or any acid, so that the enzyme gets denatured, and the color is maintained for reading. Or you can do the reading in a ELISA reader and take the optical density, and then you can draw a standard curve of the standards, and then quantify the assay. So very very good techniques. These are the ones which are nowadays done in almost every laboratory, in immunology laboratory, and the only thing is that the person has to learn the way you have to do the washings, and incubations have to be done at proper temperature. Normally all the antibody incubations are done at 37 degrees centigrade. Coating step can be done overnight at 4 degrees centigrade also, and final the reaction should be stopped after 20 minutes, and the reading should be taken as soon as possible, because once you keep the substrate for some time, it gets hydrolyzed and the colors they change, and you will not be able to appreciate a proper reaction, and the quantification can be faulty. So these are some of the points which need to be taken into consideration, and you can do ELISAs and enjoy these techniques very nicely. So thank you very much for listening, and next time we will try to cover the immunofluorescence assays, which are also amazing technique and can be done, and they have their own applications, for the detection of antigen as well as antibodies. Thank you very much, and goodbye.